So let's start with lines. A line is the graph of a linear equation. And I hope you guys were sitting down for that, because that is like the world's most earth-shattering news, right?
Stop it.
But that's one way of defining a line. Another way, which I was presented this in my graduate studies, it gives you a little bit more of a visual. It's a series of points that extend indefinitely in opposite directions.
Emotional damage.
I'm sure we all can visualize what a line is. I'm not going to, get us bogged down with that.
Nope.
One important feature of a line, though, is something called the line slope, which I'm sure you may have heard of before in the past, especially if you've worked with lines. And a slope is something that we can calculate when the line is in the coordinate plane. And how you calculate it is by forming a ratio or a fraction. And this fraction will have a numerator and denominator, obviously. And in the numerator, we have what's called a vertical change. And in the denominator, we have what's referred to as a horizontal change. And these changes are calculated by taking 2 points that are on the line, and it can be any 2 points. And so this ratio of the vertical change to horizontal change between any 2 points will always give you the same number. And that's why it says here is always a constant value. And this constant value, or this number that you get when you form these ratios, is known as line slope. And we typically indicate that with the letter M. So I have a diagram with 2 points on a line, generic coordinates, and that's because I want to give you one version of slope that involves a formula. And in the box to the right, you can see that I'll be giving you a total of 3 versions of slope. The first version of slope involves these expressions, vertical change and horizontal change. Let's imagine that we're at the point with coordinates x1, y1, and we want to travel to the point x2, y2, but we're only allowed to move left, right, up, and down. So there's no traveling diagonally. One way to get from the point x1, y1 to the point x2, y2 is to go as far to the right as possible until you're underneath the point x2, y2. And this is what we mean by horizontal change. And horizontal change can be more succinctly described as a run. Horizontal change and run are interchangeable. Now that we're underneath the point x2, y2, we can go up to that point to finally reach our destination. And how far we go up is what we mean by the vertical change. And there's an R word for this as well. It's rise, exactly. Yep. So vertical change is interchangeable with the word rise. Rise over run, exactly.
Affirmative.
So keep in mind that the slope is a ratio of the vertical change to the horizontal change. And so my first version of slope for you folks is rise over run. And this is a good form of slope to have when we're trying to calculate an actual number for it based on a graph that's already provided to us. The next version is helpful when we have 2 points on the line, like we do here, and we want to calculate the slope using their coordinates. So I'm going to label the x-axis and y-axis based on how these points are written out. So I'm back down at this bottom point. Directly underneath it on the x-axis will be its x-coordinate of x1, and directly to the left of it on the y-axis will be the y-coordinate y1, and I'll do the same with the very top point. If we look at the x-axis, there's this gap between x1 and x2. The length of this gap happens to be the same length as the run that we've indicated. And so we can figure out how much the run is by figuring out how much is separating x1 and x2.
Affirmative.
And to figure out how far apart x1 and x2 are from each other, we can just subtract them, x2 minus x1. That would give us the length of the gap, which in turn gives us the length of the run. The gap that's separating y2 and y1 is found the same way. You can subtract y2 minus y1 to figure out how long that gap is separating y1 and y2, but it would also match up with how long the rise is. And since slope is rise over run,
I'm going to do what's called a pro gamer move.
We can replace the word rise with an expression, and that would be y2 minus y1. And then the run can get replaced by x2 minus x1. All right, and this is a helpful version of slope to have when your instructions don't necessarily give you the graph of the line, but maybe a couple points that are on it. And have you guys seen this version of slope before? Rock on. Now I do want to let you know that this is equivalent to y1 minus y2.
Bruh.
So you can switch the y values on top, but you have to make sure you switch the x values on the bottom as well.
Lord
So
have
if you're
mercy.
going to do y1 minus y2, be sure to do x1 minus x2 on the bottom. So in other words, the subscripts have to go in the same order. So in the first version, it goes 2 and then 1, 2 and then 1. In the second version, it goes 1 and then 2, and then 1 and then 2.
We must stay focused, brothers.
The last version of slope is helpful for application problems. Have any of you folks seen this type of notation before? The triangle in front of a variable? Maybe if you've taken like chemistry or physics or anything like that. Exactly, yep. This triangle is the Greek letter D, the capital version of it, actually. And its proper name is delta. And in the context of math application problems, or math-y type of application problems, it can sometimes refer to the expression change in ... So with this very last version of M, we can read this off as change in y over change in x. It's helpful for application problems because we can model what's called a rate of change in this format. Okay, so things that are changing over time.
Lord have mercy.